Hi! In this video, we are going to talk about the differences between ridge regression and lasso, which both are regression methods that can be used to estimate the coefficients of the linear regression model. So the estimates can be achieved by minimizing the penalized residual sum of squares. In the case of ridge regression, we use the squared L2 penalty term, and for the lasso, we use the L1 penalty. These minimization problems are equivalent to minimizing the residual sum of squares subject to a certain budget. Again, for ridge regression, this budget is given by the L2 norm of the coefficients and for the lasso by the L1 norm. Now, these two problems look quite similar, but the estimates behave very differently. Ridge regression shrinks the coefficients towards zero, but the coefficients are never set to exactly zero. Lasso, on the other hand, can produce a model with any number of predictors. So where does this difference arise? In the picture, the least square solution is denoted by beta hat, and the red lines are the contours of the residual sum of squares. The blue area are the constraint regions. The lasso and ridge regression coefficient estimates are given by the first point at which the ellipse touches the constraint region. And here in the picture, this is marked by the purple dot. So notice that the L2 pole is round with no sharp edges, so the intersection doesn't prefer any specific point. This means that the intersection will not generally occur on an axis. And so the ridge regression coefficient estimates will not be zero. L1 pole, on the other hand, it is a side square with corners on the axis. So the ellipse will often intersect the constraint region at an axis. This means that one of the coefficients is often set to zero. And in the higher dimensions, many of the coefficient estimates may be equal to zero at the same time. And this is why lasso enforces sparsity, but ridge regression doesn't. Ridge regression will always include all the variables in the model, although the magnitude of coefficient estimates depends on the tuning parameter lambda. Shrinking the coefficient estimates towards zero introduces a small bias but can reduce the variance significantly. This leads to better prediction accuracy. Lasso also shrinks the coefficients and gives better prediction accuracy, but unlike ridge regression, it can set the coefficient estimates to exactly zero. Depending on lambda, lasso can produce a model with any number of variables. That's why lasso can be used for feature selection. Well, a natural question that arises is, should you use ridge regression or lasso with your data? In general, if you have dense data, meaning that most of the predictors are related to response, so meaning that the betas are large, ridge regression tends to perform better. If there are only few relevant predictors, you should use lasso. Lasso will automatically try to find the relevant predictors, setting the rest to zero. And this is called feature selection. Remember also that ridge regression has an analytic solution, whereas with lasso we need to use some numerical methods.